Rail Up, the future mobility podcast with innovators and leaders of the ecosystem. Presented by Sebastian Sperker.
In this episode, we are joined by Sam De Smet, the co-founder of OTIV, one of Europe's leading pioneers in autonomous rail technology. Together, we will explore the exciting journey of OTIV from early advancements in shunting supervision to the vision of full autonomy on the mainline. We will also dive into the key topics such as the sea level of a loco driver and a groundbreaking solution that could redefine the future of the homologation processes in Europe. Tune in of this fascinating conversation. Let's start. Hi Sam, welcome to RAILUP. Let's start with the question. So Sam, are you rather an innovator or a leader?
Hi, Sebastian. It's first of all, thanks for having me on. It's a pleasure to be here. I knew you were going to ask this question, right? So I thought about this. I believe that if you want to make a change in the world, I believe you need to be both. With OTIV, we're really establishing ourselves as a young player with a revolutionary technology in an industry that I would say has seen consolidation rather than seeing a lot of new companies. So I like to see myself as leader of a team of innovators to achieve something together where we can innovate collectively at a higher level.
Today we will once again dive into the world of autonomous rail driving. And in the previous episodes we spoke about autonomous self-propelled rail cars, discussed the Hyperloop and system with autonomous levitating pods. However, in various discussions over the past years, I've often heard that these technologies might be still too futuristic or represents a too big step for the industry. And that actually raises the question, what could be an intermediate step? And I believe Sam has the best answer to this, as OT focus on various stages of automation, from camera systems to supervised remote loco drivers. So Sam, let's get started and let's start with you. How did you come to work in the rail tech company?
I had nothing with rail actually before. I graduated in business. I joined consulting for 4 or 5 years. I worked for Roland Berger and afterwards for BCG. So doing projects all across Europe, even worked in Africa, worked in China. Doing there a fair amount of transportation and mobility projects. I did rail, I did aviation, I did trucking. Since I do have a natural affinity for things that move, I would say. Consulting, it's a whole lot of fun. It's very motivating to work with bright people that are eager to make an impact. But then at some point you ask yourself, do I want to stay on the sidelines supporting the strategy of big corporates, or do I actually want to jump in myself? Do I want to put my own boots on the ground? And that's where this story started. Actually, I reconnected with my co-founder Niels. We were very good friends at university. And he worked on industrial automation systems, had an experience working in Silicon Valley, came back with a wild idea of automation in rail. Then we said, okay, do we aim to build an autonomous car company? Actually, the answer was no. So we started looking at a problem we wanted to solve. And the start was trams, actually. So autonomous trams. Let's make trams autonomous. We started working on the idea from there. And it made sense in terms of technology, timing, and market. And I actually considered this as a consulting project at the beginning when we first started, because what's crucial in consulting is understanding a market dynamics in a couple of weeks. That's really a skill that helped me a lot. And from there, we started putting the pieces together.
The name OTIV sounds actually quite sophisticated. Is the name an acronym, or how you set the name?
It's a great question, Sebastian. The answer is very simple. We thought about locomotive, we thought about loco, and then we thought about OTIV. So
Okay.
we think it's a perfect name for what we do.
Okay, perfect.
A very long brainstorming session, as you can imagine.
With a lot of beers probably involved. No, but let's coming back. So which problem you're aiming to solve with OTIV?
So actually, we started with the trams because that was, from a technology point of view, an interesting problem to solve. But then actually we went and took a step back. Okay, what can we actually solve with automation technology in the rail space? And then we didn't solely define trams, but we also looked at industrial sites. We also looked at mainline rail. And we do see a couple of challenges that hold back rail from reaching its full potential. I think we all know these challenges, right? And that's what really drives us day after day. It's the fact that, as I said, rail is not living up to its full potential. Um, and it's also the reason why we do rail. It's a question that I get often. I mean, we're a startup, a scale up by now, I would say. And people very often ask me, why on earth did you start a company in such a conservative industry? Um, and the answer is because we believe in it, because we need it, because we need a sustainable, energy efficient way of transporting goods and people. And we actually have that. It's rail, but it's just not living up to its full potential. We see driver shortages, we see cost disadvantages, we see insufficient reliability, insufficient flexibility, and that's where we believe that automation can actually solve part of that equation. Maybe to expand on the bringing automation to rail, what's crucial and what's unique about the approach that we have at OTIV is that we don't go from zero to full autonomous, as you said earlier. We don't go from zero to full autonomous in one shot. We do this in a stepwise approach where we actually have an underlying technology, an underlying brain that we teach a brain that we teach to drive railway vehicles autonomously, but we use that brain to actually develop 3 stages of products. So we start with driver assistance. Driver assistance is avoiding collisions, helping drivers to operate their train in a safe way. That's step 1. Step 2 is taking that driver out of the cabin and letting him or her drive the train from an office. So that's tele-operation, that's remote operation. This is for us a crucial step in between. And then the third step is obviously the full autonomous, the vision towards full automation. We believe that automation in rail can actually only be successful if we apply this stepwise approach.
That actually sounds like a feasible approach. And you mentioned in our pre-talks that OTIF should become like the brain of the locomotive in order to utilize it much more efficient, cheaper, and that's with remote control, right?
Yeah, exactly. So with automation, we can solve the driver shortages. We can solve the cost inefficiencies. We can solve a lot of the flexibility and reliability challenges that we have today. And we believe that, as I said, with automation, we can solve this. With remote operation, we can already tackle a huge chunk of this. That's why we believe really in this remote operation step, not just as a fallback for when your autonomous system is not performing as it should in the future, but really as a step in between, as a product, as a service in between, where we go from today towards really remotely operating trains.
And you have also structured your product, what you see on the webpage, quite like easy. It's like OTIF 1, 2, 3, 4, and that's the various steps actually of automation. But I mean, I think the very important or interesting question would be like, let's talk a little bit about the timeline, right? I mean, we do understand like there will be a big challenge, a big change ongoing, but can you just give us like a timeline of the supervised one, then the remote one, then the autonomous one?
Yeah, sure. 25 is actually a huge year for OTIF because we're deploying, we're putting live our driver assistance systems. We're going to roughly 15 industrial sites. We're going to 8 cities to actually put this live. That is the driver assistance segment, and then in parallel, we're going live with both our remote operation systems. So for one of the largest freight operators in Europe, there we're going towards a full 1-year operational test. And on top of that, we launched a test for the full automation stack on the urban segment. So this year is really a year of deployment, let's say. In terms of when we look at full deployments, when we look at full let's say full rollouts, we also know that if we look at industrial sites, if we look at trams, let's say the controlled areas, for example, the depot of the workshop, we expect this to be possible to go towards full automation in 26, 27, while looking at mainline and probably the trams in non-controlled environments. There we're looking more at 2030, 2032.
And let's speak about OTIV too. As far as understood, this is more or less like a driver assistance for a tram in urban areas rather than a tool for the railway mainline.
Exactly. So what we thought with, or what we saw with this this segment is we actually always try to solve problems of customers, and what we saw in this segment is that the trams driving around in cities, while all the cars have some sort of collision avoidance system, some sort of warning system, actually the trams don't have any, and the trams drive around steel on steel, which is obviously from a physics point of view.
Perfect. 4 times more energy efficient.
Exactly. That's why we love rail, right? Because
Yeah,
from a
exactly.
physics point of view, that's what you need. That's the most efficient way.
That's the magic.
Exactly. But from a braking curve point of view, that's less interesting. So it came as quite a surprise to us that while all the cars have collision avoidance systems, on trams you didn't have this. So that's why we moved in this space, and that's where we're deploying now in as I said, in 8 cities this year, to actually make this possible and to bring safety to this first segment. And obviously this builds on our autonomously driving brain. So all the data that we're gathering here, all the insights that we get, all the learnings that we do also throughout these drive, basically the system becomes smarter every kilometer driven, and that's the entire underlying strategy towards full automation.
In this segment, like who is actually there your customer? Is it like the public transport provider or is it the OEM who produces the tram?
Yeah, there we work with both. We work with some of the public transport operators directly, and we work with some of the OEMs as well. And that's it's an interesting point actually, Sebastian. That it's interesting that you asked, because what I believe is that in rail, it is important to solve the problems of your end customers. And even we haven't spoken about the end customers. I mean, the end customer for a tram, it's actually the persons in the street that are using it. It's the same for freight. We're very often talking within the rail industry. We're very often talking about the OEMs, or we're talking about the operators. We're actually not enough talking about what can we do to bring better service to the actual customers, which is
Absolutely. Yeah.
which is not the OEMs, which is not the operators. It's actually the industrial operators, like big steel mills or big chemical players. And that's a focus that we believe at OTIV is sometimes lacking in the industry, and that we really want to bring in. That's our entire, let's say, the entire value that we have at OTIV.
Yeah. We heard it like in previous episode already, like that this is something that's really the missing link actually, to really talk about the needs of the customer, not the needs of a specific carrier or OEM. Okay, and then let's jump to the next product category, which is also quite interesting. That's the remote driving. So basically, I can imagine you testing it on a specific stretch, and really, like as far as I stood, the one local it's a local driver, a licensed one, is sitting in like an office and steering a locomotive which is running on the network, and like in the cabin there is not anymore any guy there, right?
Absolutely. That's the vision. So the vision that we have there is that once you can remotely drive a train, and again, it can go on an industrial site, it can go on an urban site, or it can go on the main line. Once you can drive that train remotely, you can actually automate. If you look at, for example, for mainline, you can do GOA4 within an ETCS system. You can automate 80% of your segment. And then for the last 20%, you might need a person to intervene, or to cover a more difficult section. That's where the remote driver can come in. And that means that the remote driver doesn't need to go to a specific site, jump on the train, drive the train, get off again, take a hotel or take a taxi back. This can be done from an office. We actually, together with our customers, we made the business case, and up to 25% of drivers' time is actually spent carrying air. So if we can already replace that 25% of driver's time that they're traveling around with air, which is basically going from the stabling yard or the shunting station to the first station where passengers get on. If we can reduce that, we have a huge reduction in manpower that we need, and as such, we have a good solution for the shortage that we have in drivers today.
Absolutely. And you talked that this year also in this segment, it's a quite important one. So you're starting like a test, and the test is really like as I described before, without any on board in the cabin anymore.
You know railway industry, right? The test is
I hope so.
the test is an operational test for 1 year, but we have a safety driver on board. So we're testing with one of the biggest freight operators in Europe on a specific section. Indeed, we have the safety driver on board, but the test is actually validating the specifications and the performance of that remote operating system. It's a very interesting process to get to a derogation for that, even though there is a test driver. But as you know, bringing innovation to rail requires quite some paperwork, and so the paperwork to get this system approved, to get this locomotive again homologated, again approved to drive on the public roads or public tracks, has been very interesting. But we're very confident to start driving in the second half of this year, and prove actually to the industry that we can do this. We can solve the technical challenge. We can solve the regulatory challenge, and then a third phase is what I call the day two problems. Let's say so. Day one problems are typically the problems where you start, where you implement, where you develop, and then you leave it with the customer. Day two is really okay. How do we keep this operational? How do we maintain? How do we service these kind of systems?
How to scale up.
Exactly.
I think from a technology point of view, it's not anymore a moonshot, or for sure not the biggest challenge. But what I can imagine is it's rather the regulatory part in which, or the frame of our use has to operate. And this is not defined by the industry, rather by the NSA. So OTIV is located in Belgium, and so where the first test run will take place?
The test drive is in the Netherlands. So we work with the ILT, which is the Dutch National Safety Authority. And the way that we approach this, not just for remote driving, but also for driver assistance, and actually also for full automation, is that we are working with a let's say a set of partners, a set of early movers that want to create the standards and want to define the regulation together with us. We as a startup, a scale up in rail, we don't have the scale to go towards the European Rail Agency or the FRA in the US to actually change that regulation. We always need a partner, and that's why we're working with some of these leaders in the industry to actually get to the derogation and get to the certification of these systems.
Okay, and what is there your expected timeline?
In terms of industrial sites and what we call controlled environments, we are actually very close to deploying these systems. If you talk industrial sites, we can do this 26, 27. If you talk mainline,
Let's talk about the big thing.
yeah. They were obviously on the track towards 2030, 2032.
Okay.
Where you need to get through the TSIs. I mean, it's as I said, technologically, we want to prove that it is possible, that there is a business case, and then we want to accelerate the TSIs. But the TSIs still need to happen, and that's also why we are working with industrial players, with urban players. We're working on shunting yards to basically cover that market before we can actually go towards mainline.
Is OTIV looking for more customer or investor, or you're super happy where you are?
Yes, we're expanding, so we're scaling our driver assistance systems. So there we see that plenty of customers are interested in taking that step. In terms of the higher levels of autonomy, we are quite selective in working with some of the early adopters towards these kind of technologies. And in terms of investors, we're actually very happy with current investors that we have, which also includes some of the LPs or limited partners, include some national railway operators, some large industrial operators, and then so the fact that as a startup or as a scale up, we're able to leverage their expertise, their network, that brings us a lot. Obviously, with 2025 being a pivotal year for OTIV, we are actually indeed looking for new partners to further speed up this story and make an even larger impact.
You teased it already, like you're working also with the RFA in the US. Is it a different approach what they are following in your opinion?
Yeah, in terms of railway market, the US is obviously completely different. Uh, I think that that's well known to everyone. I mean, there's in freight there's a class one operators and then a whole lot of these smaller short line operators. There we are currently. We actually started in October, so we have someone in the US breaking the molds, let's say, getting European technology into the US railway market. And there we're starting again with our driver assistance system. So we're taking the same stepwise approach with the driver assistance systems and then towards tele-operation and full autonomous. With the FRA, we'll have to follow the same steps as we're doing with the European regulators. In terms of, let's say, vision towards automation, what we see is that there is a willingness to go towards automation. What we see in compared to Europe is that what we are quite strong at in Europe is all the efforts that you see in ERGU in terms of going towards at least the ETCS part and then the ATO part. That, let's say, industry coming together element is not there in the US today. So it's more of an individual approach that they have.
Okay, and they are, I guess, mainly like the class 2 or the short liners, right?
Yeah. So for the short liners, I mean, all the work that we're doing on shunting, these are extremely interesting for our use cases as well.
Yeah, absolutely. You already mentioned it, ETCS, basically, but all these technology, like what you're following, is based on ETCS, right?
That is the case for mainline. Again, what we are building is the brain for driving the vehicle autonomously, and we actually build the brain so it can work without a train protection system. So it can work on industrial sites, it can work in ports, it can work in cities, and we also want it to work on Class B systems. And obviously, ETCS is actually the ideal, the easiest solution. But we don't need, in our vision, we don't need ETCS, and we actually don't want to wait for ETCS to take that step towards full automation.
Let's talk about safety and the various safety integrity levels, the so-called SEALs. That's a crucial point when we talk about autonomous driving. But there is one big problem. In order to test and to get an homologation, you need basically to prove that the new system is it's a minimum at the same SEAL level as the current operations or better. And to demonstrate that, you need references, or in easy words, you need a data set to match. But exactly this data set is not available, at least not for the lower SEAL level. So how you address this challenge?
The problem basically comes down to what is the SIL level of a driver,
Okay.
right?
Yeah.
That's what we're trying to solve for. What we do is there we take a look at what our colleagues do in automotive, because that is obviously a sector where they're moving a bit forward with regards to automation, and basically there's two big steps that we are taking. First, it's real life testing, so it's kilometers driven and it's statistics that we are building based on the amount of interventions that an actual driver still needs to take. That is one, and secondly, it is simulation. Simulation is critical in building and improving that your system is actually reliable on a statistical level. If you work with a closed box, if you're looking at perception systems which are based on AI algorithms, you are in a black box. So you can only measure actually the output of your system, and the only way to measure and to compare the output is by looking at statistics, looking at amount of interventions and actually the statistical performance of your system.
Of your system, but how you match then your performance of the system to which is already like in an one approved data set which you can match against it?
No. The answer is no. The answer is no, and then that's indeed the regulatory void that we are in, and that for a large part, automotive is also still in. Again, where we can move forward faster on these is these controlled environments where if you talk about a steel mill, 90% of what they do is already fully automated. So you can if you can build the safety case there, we are actually gathering the data there. We build the safety case for that customer, but we actually extract from those systems that are live. We can actually extract safety relevant data to actually prove this also for mainline, because obviously for mainline you are in a vicious circle. If you can't test because you're not allowed to test to get on the tracks, then you can't gather data. And if you can't gather data, you can never get approved, so you can't test. So that's a bit of the vicious circle that we try to solve by going through these different rail environments.
And how the automotive industry solve this problem?
The problem, you mean the problem of showing that it's better than a human driver? Again, statistics. That's the only way to solve this.
I don't know if you told me the story, but basically that one of the breakthrough was like an American electric car manufacturer. Basically, he challenged, or the company challenged the insurance data, like how often like accidents happens, because the insurance knows, and that was more or less than the reference to if autonomous or like a pilot kind of is it a better way or not.
Exactly, and that's what I mean by statistics. And the statistics boil down to number of accidents per 100 kilometers driven, for example. And those kind of statistics, those are the ones that you can compare to.
That's the challenge, and basically one of my questions is always like, what do you see as one of the biggest challenge to innovate the rail sector in Europe? So we had the regulatory part. What else do you see like really as a big block on the road to get over it?
Yeah, I want to say it's maybe a bit of an out of the box answer, but it is focus on the customer. Again, we move goods and people. The question is, how do we move goods and people in the most efficient manner? We're not driving trains, or we're not driving around with trains just for the sake of driving around with trains. We're actually doing this for our end customer, and that's sometimes an overlooked element. While for us, for me at OTIV, this is key. And maybe I can give you an anecdote of how we actually first interacted with our first customers, because that was not a railway company. It was an industrial operator, one of the biggest steel mills in Europe, with hundreds of kilometers of tracks on their sites. And it was one of our first meetings, even before formally starting OTIV. We came into the discussion with our vision towards fully automating the rail on their site, and they actually said, okay, we understand that you want to go towards full automation, but what we then did was listen to the problems that they have. We listened to their what their needs are, and that's where it clicked for me. Actually, what we need to succeed for rail to become better is to listen to the customers, and that's how we, for example, are not just going from zero to full automation in one go. We're not imposing that one solution to the industry. No, we're going towards a stepwise approach, and we're actually solving the problems of our customers. So we need to build products that our customers, which is again not the OEMs, not the operators, but the shippers, can use.
Good. And then I have a provocative question, but maybe not to you, but basically talking to the customers. If we talk about in Europe about innovation in the ecosystem of rail, we have these mainly two buzzwords, ETCS and also the digital automatic coupling. So what do you think about the DAC? Is basically is the end customer ask if the DAC really solves the problem? So what is your opinion on the DAC?
I have a slightly outsider perspective, obviously, on duck. It was something when I first encountered it, when I first came into the industry. For me, it was absolutely mind blowing. First of all, that a 19th century coupling system is still responsible for guaranteeing the safety of what we're doing. Um, so as I said, I followed the discussion from a distance. What I feel is a fair amount of frustration and cynicism about it being deployed. Um, for me, from a technological point of view, I believe that it's an absolute necessity to go towards a system that is able to connect, to monitor these freight cars. That's it's absolutely a condition to go towards, let's say, an integrated system. Now, we're not even talking about automation, but at least an integrated system that has the potential to be automated in the future.
Do you think it will be really implemented one day? Like now we're talking about 2030, 2035.
Can I return the question to you? That's no. I mean, it's for me in terms of technology. This is a technology that should have been there 10 years ago already.
50, I would say.
Yeah. Okay. Fair. Fair. Um. Full stop.
Okay. Okay. Good. And then let's talk a little bit about the future. So basically OTIF is like shaping the future. What do you see or how you see the role of AI like in the future, Rail?
Obviously, if you look at AI, for me, there's three, I would say, three elements that we look at. First of all, is obviously automation. It's an important element in all the perception systems that also we are building. So the core of our brain is an AI system that is gathering all this information and processing all of this. Um, Next to that, there's obviously good amount of applications that you can have in maintenance, in preventive maintenance, in scheduling. I believe a good amount of work can be done there. Um, what's crucial for me is, again, I'm coming back to this focus on service. What can we do? How can we actually apply these technologies to make rail more efficient and to make rail more flexible, more reliable for the customers? So if that is a planning tool that works better instead of the planning process that is happening today, then I would definitely applaud that.
And when we speak about technologies, how your team at OTIF looks like, what is the share between the software engineers and the hardware engineers?
We're currently 35, of which the biggest chunk is in engineering. I would say I think 28 people, and there the largest amount of people at OTIF, of the crew here, is actually working on the software. We also have to work on hardware, obviously, because we are actually integrating. We are testing sensors. We are validating sensors. We are doing a lot of important work on the hardware. Um, today, there is a big focus on software development and getting that, basically building that brain.
There's now the new administration in the US, and basically now also what is ongoing in Europe. Basically, we're shifting the priorities as well. And like the Green Deal, which was like the narrative for the last 5 years, seems to be losing momentum. What do you see, like, or how as a company is there already also changes ongoing on your side that you feel it or see it, or
A couple of answers to the question. The US question is obviously an interesting one. If we look at the start of our commercial adventure, I would say in the US, actually we see a lot of enthusiasm about the measures that are taken, because obviously within the US, this will further increase production and as such also rail freight. On a more macro level, what we see, if we look at the European side, is basically the biggest customers that we have, which is then the chemical plants, the steel manufacturing plants, are under pressure. And this is not it's not a new thing, right? it's not since the beginning of the year. Volumes have been going down. And what I believe and what we also want to contribute to is that um, making this system more performant can actually increase the competitiveness of your entire economy and your entire society. So that's also the reason why some of these industrial players work directly with us. Um, yeah, because what they see is that, okay, 80%, 90% of what we do on our sites is already automated. The trains still drive around like they did 100 years ago. Let's bring that level of automation, that level of efficiency also to our on-site rail. Maybe a last element, and that's a discussion that we actually had a couple of weeks ago with one of the large ports in Europe, is in terms of military spending. There is also a large or significant aspect in military mobility, which is supported by rail. So it's, if you would ask me, is it plus or minus? I would say it's a mix of all these factors. What's crucial is that rail is not going away soon, but we need to make sure that there is a future for rail. And we need to take that step. We need to take daring steps. In a crisis, you need to be able to take daring steps. You need to be able to be courageous and to take steps towards basically safeguarding this industry from losing further volumes to, for example, trucking.
No, I mean, this would have been already really, really nice closing words, but I have three more questions. So, talking about like the innovation, what you said, and we need to change. As you're one of the front runner in Europe up to doing that, what other companies do you see on the horizon who can reshape the ecosystem of rail?
It's great to see that there's a couple of companies that are looking at automation, at looking how can we rethink this system. There's also obviously a couple of the names that you mentioned, like Parallel, like Etromotive, like Nivomo. Also a couple of players working more on the software, on the perception part. To be honest, the way that I look at this is, it is good for the industry, it is healthy for the industry to at least, or at last, I would say, have a number of new entrants. As I said, the industry has been consolidating for the last 20, 30 years, with very, very little influx of new, fresh competitors, new, fresh ideas. And I believe with all of us, and we actually have quite good contacts with you could call our competitors. With all of us, we're actually there's more than enough market. With all of us, we're actually pulling on the same chords and trying to open doors for new companies, for innovation, for automation, for testing, for opening the doors towards getting these types of technologies approved, because that's what we can all profit from.
Good to hear. And if you would change to politics and you would be the Ministry of Transport, what would be your agenda?
I would say, if you look at the long term vision, because I want politics to work more on long term vision and less on extinguishing fires of the day before. I think we all want that, by the way. If I look at the long term vision, so how do I look at transportation and mobility in the future? I would look at it as a system, as an entire system, and I would take the steps towards making it really an interconnected system where every transport mode is allocated to the right piece of the puzzle. Where we have our trucking for the first and last mile, we are not against trucking. Obviously, we are pro rail, but we are not against trucking for the last mile. Probably for some parts of a last mile, you still need trucking, and let's work together to solve that and to make that into an efficient whole. I mean, if we look at some of our customers, it's a beautiful example. We work with a company within the SNCF group. They do the intermodal transport, so they put trucks on the tracks in the north of France, and they take them off in the south of France, and they basically create a highway for trucks, but they're not on the highway; they're actually on trains, and that's in my vision the system we should work towards, where we have let's say the optimal use of our scarce resources, optimal use of our networks, and start incentivizing that.
And basically having a much better CO2 footprint by doing that.
Exactly. We talked about physics. It is indeed, if you can move large amounts of goods and people, steel over steel, that is obviously the most efficient way of doing this, and that's also the big driver that we have here at OTIV. We need rail. We need sustainable transportation for the future.
Absolutely. And the future, like how you would envision the rail industry by 2050?
What I would see is an integrated autonomous system that is interconnected, and where there is let's say a standardized interface between the first and last mile trucking solutions, the first and last mile rail car solutions, because we haven't talked a lot about that. For example, the innovation that the guys at Parallel do. I have a huge amount of respect for them. I think there's compatibility between what we are building, what they are building. So what I see is that this system is interconnected, and there is, for the backbone of the transportation, it is rail. It's as simple as that.
That's some good closing words. Sam, thank you very much to be like in the RAILUP podcast. It was a pleasure to talking to you and inspiring. And I just heard you going skiing now to Austria.
That is true. That is
Which
true.
also
Looking forward to that.
on the weekend. Thank you very much. Welcome to the RAILUP Club, Sam.
Thank you very much, Sebastian. It was a pleasure.
What is the contribution to drive climate change?
OTIV driving a company where we can make an impact towards a modal shift. And we all know that a modal shift towards rail has a direct impact on climate. If we take the example, one train replaces 50 trucks and emits 9 times less CO2. That's the commitment I'm making.
The ball is in your court. What is the next step to drive change?
The next step is for the industry to take bold choices, or to make bold moves towards actually testing and validating, being open to validating these kinds of technologies, where we go towards automation, where we prove actually the safety, the reliability, and the operational efficiency of these automation systems.
Which superhero do we need to avoid the climate disaster?
Railman, no. I would say the regulatory superhero that allows us to do testing easily in an efficient way, together with the leading players, to actually show that we can make this work.
What's the takeaway from this episode?
My key takeaway from our episode is there is a need to build an environment that truly welcomes the testing of new technologies to shape the future of rail. Imagine a rail ecosystem that isn't stuck in the past, but one that's continuously evolving. It all starts by setting a solid safety benchmark and dataset to measure and compare new innovations. What really caught my attention is OTIV's step-by-step strategy. Instead of trying to jump straight into full autonomy, they are taking a measured approach, starting with shunting operations, then progressing to remote driving, and finally moving toward to fully autonomous trains. At the core of this strategy is a focus on the end user. It isn't not just about meeting the needs of the operators or manufacturers, it's about delivering a service that works for the people and customers who actually rely on rail every day. Ultimately, the vision is to build a seamless, interconnected transport network that transforms traditional rail and even new technologies like Hyperloop, paving the way for more efficient, sustainable and forward-thinking future. And that's the spirit of RAILUP.
This podcast connects innovators and leaders worldwide to shape the future ecosystem of rail. Rail Up by Sebastian Sperker.